All right, so now three subsets is the next thing you're going to learn after two subsets. And we're going to work on that very quickly. Well, let's just start with a brief introduction of what it's all about. Now, three subset involves three sets. They could give you physics, chemistry, biology, three sets. They could give you three modes of transportation, three sets. They could give you three languages, three sets. Now, these are just forms of three sets. You can put them in a Venn diagram representing it like this, where this is set of A, and this is set of B, this is set of C. So this is how you draw your Venn diagram. But what formula are we going to use? The formula is going to be different totally from the two subsets you've been working on. Now, take note that in the two subsets, we used the union, A union B, and then we found the formula. But this time, we're dealing with A union B union C. So what will this be equal to? This will be equal to number of A plus number of B plus number of C. And then we will subtract all the intersection. So that will be minus number of A intersection B minus number of A intersection C minus number of A intersection, this will be B intersection C. And finally, we'll add the intersection for all of them. A intersection B intersection C. And this is the formula. So take note if you want to remember the formula. Add the individual sets A, B, and C. Then subtract all the intersections possible. And add the final intersection for three sets. That's simple. So this is the three subset formula. All right. Now there's something I want to just add. You need to know the different aspects of the Venn diagram. The reason is because they give you questions that sometimes you don't know where to place elements. So for example, if you have a Venn diagram like this, all right, so this is a Venn diagram. I'm just putting two just in case I make mistake on one. Now the first diagram contains three sets as usual. The set of A, the set of B, and the set of C. We're going to explain the individual parts of this Venn diagram. You notice there are different spaces or structures in this diagram. So what is this part here? Now this part here is not included in B and C, but is only included in A. So we'll call this only A. The same thing with this B. It's only B. It's not included in A and C, and this is only C. What of the middle part? The middle part is included in both A, B, and C. So it is a common element for A, B, and C, and naturally in set we'll call that intersection. So it is the intersection for A, B, and C. All right? What about this part here, and this part, and this part? Now take note of the fact that it is an intersection for just B, A, and B. This part here is an intersection for just A and B, but only A and B. You need to understand that if this is set A and this is set B, this part here is the complete intersection for A and B. But we're just talking about only this part here. So this part, even though it's the intersection, this time to be referred to as only A intersection B. That means this part here will be only B intersection C, and this part here will be only A intersection C. So this is important that you should know. All right. So now that we know these individual parts in a Venn diagram, how do we use this type of Venn diagram? How do we solve questions on Venn diagrams like this? Well, we're going to do that in the next video.